Have you ever looked up at the night sky and felt a sense of wonder, a feeling of connection to something vast and ancient? Now imagine for a moment that we could take our entire home, our solar system, the sun, the earth, all the planets, and move it. Not just to another star system, but to an entirely new galaxy. We are relocating to our nearest grand neighbor, the Andromeda galaxy. This isn't just a simple change of address. It's a complete rewriting of our celestial story. A shift in our cosmic perspective that would change everything we think we know about our place in the universe. So where have we moved to? What is this new home of ours? The Andromeda galaxy, also known by its catalog number Messier 31, is the largest member of our local group of galaxies. It is a majestic spiral, much like our own Milky Way but on a grander scale. Think of it as the big city to our familiar town. It is a sprawling metropolis of stars, containing perhaps as many as 1 trillion suns, which is more than double the estimated number in our own galaxy. Its sheer size is difficult to comprehend. A river of stars stretching over 200,000 light-years from one end to the other, a vast spinning disk of cosmic wonder. At the heart of this celestial giant lies not one but 2 supermassive black holes, locked in a tight gravitational embrace. This double-core structure is a clue to Andromeda's violent and dynamic past, a history of consuming smaller galaxies to fuel its growth, a cosmic cannibal that has built its empire over billions of years. While both the Milky Way and Andromeda are beautiful spiral galaxies, they possess distinct personalities. The most obvious difference, as we've seen, is size. Andromeda is the undisputed heavyweight champion of our local group. If you could place them side by side, the Milky Way would look noticeably smaller and less populated. The Milky Way is classified as a barred spiral galaxy. This means it has a large, central bar-shaped structure composed of stars, from which its spiral arms emerge. Andromeda, on the other hand, appears to be a more classic spiral galaxy, lacking such a prominent central bar. Its arms seem to unwind more directly from its bright, dense core. Andromeda appears to have had a more violent past, evidenced by its complex structure, its massive stellar halo, and the remnants of smaller galaxies it has absorbed over cosmic time. It is a galaxy built from conquest. We would be living inside a galactic empire, built on the ruins of others. The Milky Way's Sagittarius A is a behemoth, weighing in at about 4 million times the mass of our Sun. It is a powerful engine at our galaxy's heart, but Andromeda's core is even more extreme. Its primary supermassive black hole is estimated to be over 100 million solar masses, a true monster lurking in the galactic center. Imagine stepping outside on a clear, moonless night. On our Earth in the Milky Way, we see a few thousand individual stars, and the faint, milky band of our own galaxy arching across the sky. Now transport yourself to our new home within Andromeda. The view would be utterly transformed. Given Andromeda's greater density of stars, the night sky would be far more crowded. The number of stars visible to the naked eye would increase dramatically. The darkness would be punctuated by a glittering tapestry of countless suns, many appearing brighter and closer than the stars we are used to seeing. The familiar constellations we trace would be gone, replaced by new patterns, new celestial myths waiting to be written. We would also be treated to a far more spectacular view of nebulae. We would see these cosmic clouds not as faint, fuzzy patches requiring a telescope, but as great, glowing swathes of color, pinks, reds, and blues, painted across the celestial canvas, visible to the naked eye. Supernovae, the explosive deaths of massive stars, would also be a more common sight. While a supernova visible to the naked eye from Earth is a once-in-a-century event, in the more active Andromeda galaxy, we might be lucky enough to witness such an event every few years. Perhaps the most profound change would be the absence of the Milky Way's band. Instead, the structure of Andromeda's own spiral arms would dominate our view. We would feel, in a very visceral way, that we were living inside a great whirlpool of stars. From our new home within Andromeda, the single most spectacular object in our night sky would be our old home, the Milky Way. But if we were living in Andromeda, the Milky Way would be an unmissable, magnificent spectacle. It would hang in our sky as a vast, bright spiral galaxy, its shape and structure laid bare for us to see in all its glory. It would be a constant, awe-inspiring presence. We would be able to see the Milky Way's bright central core, the glowing bar of stars at its heart, and its graceful spiral arms winding outwards. With a simple pair of binoculars, we could resolve individual star clouds and bright nebulae within its arms, the very regions we currently struggle to map from our position inside it. We would have a perfect external view of our former home, a cosmic perspective that astronomers on Earth can only dream of achieving. This view would revolutionize our understanding of galaxies. We could study the Milky Way's overall structure, its rate of star formation, and its dynamics with unparalleled clarity. We could watch as supernova explosions flash within its arms and track the movement of its star clusters. The emotional and philosophical impact would be honestly profound. Every time we looked up, we'd see the galaxy we came from. It would be a celestial reminder of our origins, a distant shore from which we have sailed. This view would instill a unique dual identity, citizens of Andromeda, with our roots lying in that beautiful distant island of stars across the intergalactic abyss. Living inside a larger, denser galaxy like Andromeda would present both incredible opportunities and formidable challenges for an advanced, spacefaring civilization. The sheer proximity of other star systems would be a game changer. In our part of the Milky Way, the nearest star to our sun, Proxima Centauri, is over 4 light-years away. But in a more crowded region of Andromeda, neighboring stars could be significantly closer, maybe only a light-year or 2 away. This would dramatically reduce the travel times for interstellar probes and eventually crewed missions. The dream of reaching another star system would feel much more attainable. The galaxy would be rich with destinations. With 1 trillion stars, the number of planetary systems to explore would be immense. The chances of finding interesting worlds, and perhaps even worlds with life, would be statistically much higher. However, this crowded environment would also introduce new dangers. The rate of supernovae would be higher, meaning the risk from sterilizing gamma-ray bursts would be greater. A nearby stellar explosion could pose a significant threat to life on Earth. Navigating through denser regions of the galaxy would also be more hazardous. Spacecraft would need to contend with more cosmic dust, micrometeoroids, and stronger gravitational fields from passing stars. The immense gravity of Andromeda's core and its more massive spiral arms would create a more complex gravitational landscape. This could be harnessed for gravity assist maneuvers on a galactic scale, slinging spacecraft across the galaxy at incredible speeds. But it would also mean that orbital mechanics would be more complicated. A stable orbit for our solar system around the galactic center might be harder to maintain over billions of years, potentially being disrupted by the passage of other massive stars or giant molecular clouds. The move to Andromeda would ignite a golden age of astronomy and physics, forcing us to rewrite our textbooks and ask questions we hadn't even thought of. The primary driver of this revolution would be our unparalleled view of the Milky Way. By studying our former galaxy as an external object, we could solve long-standing mysteries about its structure, formation, and evolution. We could map its dark matter halo with incredible precision by observing its gravitational effects on the stars in its disk. Our understanding of galactic dynamics would be transformed. Andromeda is a laboratory of cosmic collisions. We would be able to observe the streams of stars from dwarf galaxies it has consumed, providing a live-action view of galactic cannibalism. Studying the complex dance of its dual supermassive black holes at the core would offer invaluable insights into the behavior of gravity in the most extreme environments. These observations could lead to breakthroughs in our understanding of general relativity and the enigmatic nature of black holes themselves. The search for extraterrestrial life, or astrobiology, would receive an enormous boost. With 1 trillion stars in our galaxy, the statistical probability of life emerging elsewhere would be far greater. The increased number of nearby star systems would make it easier to scan their planets for biosignatures, the chemical fingerprints of life in their atmospheres. The famous Drake equation, which estimates the number of active communicative civilizations in our galaxy, would yield a much more optimistic result. However, new mysteries would also present themselves. We might discover entirely new astronomical phenomena unique to a galaxy as massive and active as Andromeda. Our position would also make it more difficult to study the distant universe. The bright, dense nature of Andromeda and the ubiquitous dust and gas would create more galactic fog, obscuring our view of faraway galaxies and the cosmic microwave background radiation. We would trade a clear view of the wider universe for a spectacular view of our local neighborhood. Living under the brilliant star-saturated sky of Andromeda would have a profound and lasting impact on human culture, mythology, and our day-to-day perception of the world. For millennia, our relationship with the sky has shaped our religions, our art, and our science. A completely different celestial display would have led to a completely different cultural evolution. Our new constellations would have inspired new myths, new gods, and new stories to explain our place in the cosmos. The sheer spectacle of the night sky would make astronomy a more central part of everyday life. Imagine a world where grand, colorful nebulae are as common a sight as clouds, and the brilliant band of a galactic arm is a nightly presence. Stargazing would not be a niche hobby, but a shared, universal experience of overwhelming beauty. This constant, visible reminder of the vastness of the cosmos could foster a more global, unified perspective among humanity. When faced with such a majestic view, our terrestrial squabbles and divisions might seem far less significant. This constant celestial light could even have biological implications. The brighter nights might affect the circadian rhythms of life on Earth, influencing the behavior of nocturnal animals, and perhaps even human sleep patterns over evolutionary timescales. Ultimately, living in Andromeda would change our very definition of home. We would be profoundly aware that we are inhabitants of a vast dynamic galaxy, not just a planet. The galaxy itself would feel like our home, and the solar system just our small neighborhood within it. This perspective shift could inspire a deeper sense of responsibility for our planet, seeing it as a precious, perhaps unique oasis of life in a bustling cosmic city. Our journey is at its end. We have moved our solar system, explored the dazzling skies of Andromeda, and pondered the ripples of change that would spread through our science and culture. It is, of course, a fantasy, a game of what if played on the grandest possible stage. We cannot physically move our world across the intergalactic void, but the power of this thought experiment is not in its practicality, but in its ability to stretch our minds. It allows us to step outside of ourselves and see our home, the Milky Way, not as a given, but as a place with its own unique character and beauty. By imagining a different home, we learn to appreciate our own. We see the relative peace of our galactic neighborhood, the clarity of our view into the deep universe, and the familiar, comforting patterns of our constellations in a new light. This act of imagination is the very essence of scientific inquiry. Science is not just about measuring and calculating what is, it is also about imagining what could be. Every great discovery began with a question, a thought experiment, a leap of faith into the unknown. By asking what if our solar system was in Andromeda, we are engaging in the same creative process that led to the theories of relativity and quantum mechanics. We are using our minds, the most powerful tool we have, to explore the vastness of the cosmos from the quiet sanctuary of our own planet. In the end, the universe is not just out there among the stars and galaxies. It is also within us, in our ability to wonder, to question, and to imagine. The story of the cosmos is the grandest story of all, and we are fortunate enough to be able to read its pages, written in the language of light across the night sky. Whether we gaze upon the gentle band of the Milky Way or the imagined splendor of Andromeda, we are partaking in a fundamental human experience, the search for our place in the universe, and that is a journey that requires no spacecraft, only a curious mind.